Believe it or not, professional storm chasers like me don't actually guess. We use a lot of different things to determine where tornadoes might form. One of those is a kind of weather cheat code that the public rarely sees. It's a specific combination of two atmospheric ingredients viewed on a single map that flags the danger zones with stunning accuracy, or at least relatively good accuracy. This is the tool that tells storm chasers like me where the action will be, and today I'm going to show you exactly how to use it. So what is this big cheat code? What is the secret I rely on out in the field? After years and years of chasing, I've learned that success isn't about luck. It's about filtering out the noise. In this case, for this cheat code, it comes down to the potent overlap of two critical factors: low-level instability and surface vorticity. I think of it like building a fire. You need fuel and you need a spark. In the atmosphere, instability is my fuel and vorticity is my spark. When I find both concentrated in the same place, I know I've found my target zone. This potent combination is visible on a special map, one I check constantly on a chase day. It's publicly available on the NOAA Storm Prediction Center's Mesoanalysis website, and it's so powerful because it pinpoints where the air is not just explosive, but also has the spin it needs to make a tornado. It has me put in the right place at the right times more times than I can count. Of course, as with all things weather, all rules are meant to be broken, and this map is always never 100% reliable, but it is one of the more reliable ones. If you're finding this useful and want to learn more about how to decode the weather like a pro, do me a favor and hit that subscribe button. We get deep into this stuff all the time. So let's take a second and talk about these two ingredients so you understand what they're all about, so you can kind of get a better feel for how they play into a chase day. First, let's talk about the fuel, low-level instability. Storm chasers, meteorologists, etc. call this 0 to 3 kilometer cape, or 3 cape for short. Don't let the name intimidate you. It simply means energy that is available for a storm in the lowest part of the atmosphere. Imagine the air near the ground is a tightly wound spring. High 3 cape values mean that spring is primed to uncoil, launching air upwards with explosive force. This powerful upward motion is the engine of a supercell thunderstorm, but it's also the force that can take spin near the ground and stretch it vertically, making it spin faster. Without that powerful low-level stretch, a tornado oftentimes has a hard time forming. Now that brings us to our spark, surface vorticity. Vorticity is just a scientific term for spin. The Storm Prediction Center chart is specifically looking for significant vertical vorticity near the ground, spin that is already happening around a vertical axis, like a weak, invisible spinning top. This spin often gets concentrated along boundaries like fronts. By itself, this broad, weak spin is harmless, but here's where it connects to our fuel. As the Storm Prediction Center's own website description says, high 3 cape favors strong low-level stretching. When a powerful storm updraft fueled by all that explosive 3 cape ingests this air that has pre-existing spin, it rapidly stretches that column of air vertically. Think of an ice skater pulling their arms in to spin faster. The same physics apply. This stretching concentrates and drastically intensifies the spin, and that is how a tornado can be born. Now, using this cheat code isn't just about finding high low-level instability or finding spin, it's about finding where they overlap. But to use this like a true pro, you need to add one final layer of analysis: context. I say this all the time, but the best chasers know that this potent combination is most dangerous when it exists within a broader environment that's already primed for supercells and tornadoes. So, after you find your 3 cape and vorticity hotspot on the Mesoanalysis site, you need to quickly check two other things: deep layer shear and LCL heights. The ultimate pro move is to find that cheat code, the overlap of low-level fuel and spin, and then confirm it's sitting in an area with strong shear to organize the storm and low cloud bases to help the tornado reach the ground. That's how you go from a good forecast to a great one. You now have the tool to find the most dangerous zones on severe weather risk days, possibly even hours before they happen. Next time there's a severe weather risk, pull up the charts and see if you can spot the cheat code in action. Let me know in the comments what you find. Stay safe and stay curious. And remember, weather's for everyone. We'll see you next time.